And here's the final result. This is the main file after we've done some testing on it. Here we're still including the XII.h. That allows you to use all the XII software modules, and also string.h, so we can do string processing. Here you notice the print function. We noticed that we were adding a lot of messages to the data log just for printing purposes, so we created a function to kind of extract that, where all it does is writes to the data log, pass it what kind of message you want as a string, and then it just puts a 0 as the code. Yeah. For check systems, doing still the basic same thing, where if something's not okay, and we're just logging it with an error to the data log using the print function. One thing we notice here is on power driver A, if it's not working, then we try to reinitialize it, and if it still isn't working, then we basically return true, like there was an error, and likewise for the rest of the subsystems. And if all of them are okay, on the ones we're worried about, then we return false, saying that no error occurred. For check water, one of the modifications we made was in how we capture the data. Instead of reading a single value, what we did instead is sample them. So we basically, over the period of a second, we take 10 samples and we average all those together in order to take our reading. We do this in order to normalize the values and make sure we're getting an accurate reading from our sensor. Let's say, for instance, whenever we called read Q1, a spike occurred of output. That would then give us invalid data, where we think it's higher than it actually was. By sampling it over, a time period, we're able to filter out all of the spikes or dips and actually get the correct value from the sensor. We also modified the minimum moisture value. The minimum moisture value is, we figure out what it is from testing using the threshold voltage. So actually using a multimeter with our sensor, we figured out that our threshold is 2.8 volts. So if it ever goes below that, that's whenever we want to say that it is adequate moisture. So what we do is, since we have a 10-bit analog to digital converter, we take 2 to the 10 divided by 3.3 volts, which is the maximum that the pin can read. So it correlates 3.3 volts to 1024. So now we have that scale. We multiply that by our threshold voltage, and then that will in turn give us what the minimum, what our desired minimum moisture value will be in respect to the 10-bit analog value, 10-bit digital value. So that's what we're using here. We're just calculating it a slightly different way, and we got this number at 2.8 volts from testing. What we also added inside of checkwater was basically a watchdog counter. What this allows us to do is get out of the loop in case we get hung here. What we're noticing is, let's say we run out of water, you're going to keep trying to add more and more water to the plants, but none is going to come, and so you're always going to be stuck here. And so what we do is, if the timer is ever greater than 8, we return. So this would only water the plant up to 8 times before we're giving the control back to the main. Okay. For a take picture, it's basically the same. What we did notice though is whenever we were trying to store the picture, timestamp has invalid characters, so we're getting error when trying to store the picture. So what we do is, every time we see an invalid character, we replace it with a period in the file name. And that's what we use to save the camera picture. But other than that, it's basically the same. For log data, we did the same thing we did similarly with the checking of the water. Instead of getting a single sample, we get an average and use that as our measurement. Okay. In the main, there were some slight modifications. We're not using the init routine. We're instead just calling nisi.init directly. Simple enough. And I'll talk about this later. What this does, we're using this value to know when we've taken a picture or haven't taken a picture. And then as before, we call it check systems. And then we do a USB.connect. We do it here is so that before it ever starts a routine, it's already connected to the computer. That way you can immediately start reading your files if you wanted to. So every 4 hours, we check to see if we've taken a picture. We do this is because if you notice that at 4:01 the remainder is 0, or at 4:05 the remainder is also 0, and so we'll constantly take pictures and log data continually throughout the hours that we're leaving divisible by 4. So by using this taken variable, we're limiting that to happen only the first time. And then after that, so once it's 5 or later, if it was for 4 o'clock, or if it was at 8, let's say, then if it's 9 or later, then it'll reset the taken variable back to no. So next time we come to the 4-hour interval, it'll take another picture and log the data again. There you go. What we also did is take picture now returns a boolean representing if an error occurred while taking a picture, and we use that to basically log if we were able to take a picture or not take a picture. And then for the LEDs, we just wrote them here directly, simple enough to make the call. So if it's less than 12 hours, turn them red. If it's more than 12 hours, then we make them blue. And again, we were still continually monitoring check water, and finally, just at the end, outside of the while, we return 1. But yeah, that's the final version of code. Click save. Yeah, after you have it ready, you can click build. If we were to build this now, we would actually get an error. Let's show that. And I'll kind of show you why that happens. Okay, so we get all these errors, actually 2 of them. If we're looking here, what it says is that in example main.o, it was defined, I guess open solenoid was defined, but it was also defined in main ISS.o, which comes from the main ISS.c. And then we also see that we have multiple definitions of the main function, both in the example main.o and the main.iss. What's actually happening is, since we have 2 main files, which is the original and our example that we created earlier, since they both have a main, and they also both have open and closed solenoid, there's overlapping in the code. To fix this, we just simply need to remove the one we don't want. Easy way to do this, so you can still have it in your project to reference it later, is simply to disable it by excluding it from the build. And so just right click, go to properties, and then check the exclude from build. Once you're done, just click OK. And then if you build it again, there you go. Your build should be successful. And then from here, you would just program your microcontroller and DC board and test out your experiment, and then make modifications as needed.